Hello student, very good morning to all of you. How are you? I hope you all are happy, healthy and fine at home. Do you remember what were we discussing yesterday? I think yesterday we just started as this point, that is the reactions of pyridine. In that, pyridine undergoes electrophilic substitution mainly at 3 positions. So that point we have discussed why pyridine undergoes electrophilic substitution mainly at 3 positions. The reason behind it, we have drawn different resonating structures actually attacking electrophile at 2 positions. We have seen what kind of the possibilities or the resonating structures are formed, and after that finally we found that on the basis of resonating structure number of when electrophile is attacked at 3 positions, then the number of resonating structure mainly found is 4 structures are there, and that means the aromatization is back, that is a stable one when electrophile attack at 3 positions, and from that we elaborated that when electrophile in pyridine in a 6-membered ring, the electrophilic substitution mainly occur at 3 positions. And now let's see that are the thing which we are discussing over here. Now let us see the reactions. Just now we have seen one reaction, now the remaining reactions. So let us see here, second one is a nitration reaction. First one is a nitration reaction. Nitration. And in a nitration reaction, how one can get the product? Pyridine on heating with KNO3 in presence of H2SO4 at 300 degrees centigrade gives nitropyridine. So that is one of the simplest reaction. Pyridine on heating with KNO3 potassium nitrate in presence of H2SO4 at 300 degrees centigrade gives 3 nitropyridine. That is a product obtained when this kind of the procedure, pyridine on heating with KNO3, H2SO4, KNO3 is known as a potassium nitrate, and H2SO4, as we know that it is a sulfuric acid. Now we know that the starting compound is a pyridine, which I am showing over here, right? This is a structure of pyridine, and when this pyridine is treated with KNO3 potassium nitrate in presence of H2SO4 at 300 degrees centigrade, the product formed will be, what would be the product? Product generally we are getting 3 nitropyridine. So that is the product generally obtained during these reactions. Let's see here how one can get the product. This is a pyridine, and as we know that numbering start from 1, 2, 3. So at 3 position there will be a nitro group, NO2 group, and therefore The name of this compound is 1, 2, 3. 3 position nitro group is there, and therefore 3 nitropyridine. 3 nitropyridine is the name of this compound. It's very easily formed with high yield. See, once again, why 3 position pyridine undergoes electrophilic substitution reaction mainly at 3 position, and first reaction is a nitration reaction. Pyridine on heating with KNO3 H2SO4 at 300 degrees centigrade gives 3 nitropyridine. So this is one of the reaction very smoothly given by this pyridine. Now let us move on to the next reaction. That next reaction we will discuss here. Let's see the reactions. Second would be the sulfonation. Second reaction is the sulfonation. Second one is the sulfonation. Second would be the sulfonation. And pyridine on heating with concentrated H2SO4 at 350 degrees centigrade gives 3-pyridine sulfonic acid. That is the sulfonation reaction. Pyridine on heating with concentrated H2SO4. Pyridine on heating with concentrated H2SO4 at 350 degrees centigrade gives 3-pyridine sulfonic acid. 3-pyridine sulfonic 3-pyridine sulfonic acid. 3-pyridine sulfonic acid. This is a product form. Look at here. Pyridine on heating with concentrated H2SO4 at 350 degrees centigrade gives 3-pyridine sulfonic acid. As we know that the starting compound would be this one. This is a pyridine. This is the structure of pyridine, as we know that. Pyridine. And when this pyridine is treated with, look at here, concentrated H2SO4. Concentrated H2SO4, and the temperature is kept around 350 degrees centigrade. It produces the product, this one, as we know that this is a product which we are getting here is a SO3H. This group is introduced at 3 position, and therefore the name of this compound is already written over there, but you can write over here 3-pyridine sulfonic acid. Sulfonic acid will be the product formed here. 3-pyridine sulfonic acid. See, once again, pyridine on heating with concentrated H2SO4 at 350 degrees centigrade gives 3-pyridine sulfonic acid. This is the starting material, pyridine. Look at here, concentrated H2SO4 and temperature is 350 degrees centigrade. It gives this as a 3-pyridine sulfonic acid. Whatever in word is written, and this represent by the chemical reactions. So now let us move on to the next third reaction. The third reaction will be let me clean the board first. And third one, third reaction will be this one. Now when bromination, you can call it as third reaction will be the bromination. Now in a bromination, what happen? Pyridine on heating with Br2 at 300 degrees centigrade gives 3-bromopyridine and 3,5-dibromopyridine. Now pyridine on heating with Br2 at 300 degrees centigrade, all high temperature reaction. Br2 at 300 degrees centigrade gives 3-bromopyridine as well as 3,5-dibromopyridine. That is a product form. It gives a mixture of the product. If you see over here, pyridine on heating with Br2 at 300 degrees centigrade gives 3-bromopyridine as well as 3,5-dibromopyridine. What they have taken as a starting material is a pyridine, and as we know that this is the structure of pyridine. When that pyridine is treated with Br2 at 300 degrees centigrade. Br2 at 300 degrees centigrade, what would be the product? The products are obtained. Mixture of the products are obtained, and those products are, I am showing over here, so you can see here 1Br attached over here, as well as another product which we are getting here. See, here is a bromine atom, and here also has a bromine atom. Look at here, the mixture of products are obtained. So do you know the IUPAC name of those compound? Yes, you can give the number. In a heterocyclic, whether it is aromatic or the non-aromatic heterocyclic compound, always give the number in a such way that the heteroatom should get the lowest possible number. According to that, nitrogen atom has one number, then 2, 3, 4, 5 and 6. That is the conventional way or the usual way for numbering this type of the compound. Now let's see at 3 position bromine, so we can call it a 3-bromopyridine. That is the IUPAC name of this compound, 3-bromopyridine. Now observe the second structure carefully, and what do you observe? What do you observe there? What do you notice there? From where whether I should give the number in a clockwise manner or anti-clockwise manner. If you observe this structure carefully, you will notice that you can give the number either clockwise manner or the anti-clockwise manner. It doesn't make any difference, because if you go this side or this way, the positions of that substituent, especially here bromine atom, will get the same number. So let's see here 1, 2, 3, 4, 5 and 6. Look at 3 and 5 position. You can clearly see there are bromine atoms are present, so you can call it as a 3, 5 dash 2 are there, so you can use as a suffix di. 3, 5 dibromopyridine, that is the IUPAC name of that compound. So this is a third reaction which we have learned here. Now the one more reaction, that is a heterogenation reaction. Let us see that the fourth reaction which we are going to discuss here now, right now. First, let me clean the board once again. Let's see here. Heterogenation, that is the fourth reaction. Heterogenation. Fourth reaction is a heterogenation. Pyridine on catalytic hydrogenation. Pyridine on catalytic hydrogenation. Pyridine on catalytic hydrogenation yields the aliphatic hydrogenation reaction. In that, pyridine on catalytic hydrogenation yields the aliphatic heterocyclic compound. Aliphatic heterocyclic compound that is a piperidine, which is a compound obtained over here. Let's see the starting compound. As we know that this is a starting compound, pyridine. Pyridine is a starting compound. Now, when it will be treated with the reagent like molecular hydrogen H2 in presence of platinum, and the temperature 25 degrees centigrade is nothing but as a room temperature, and the atmosphere, high atmosphere, 3 atmosphere is kept over there, and by maintaining these reaction condition yielding the product, you can see here the product which you are going to get. This is a product you have got over here. Here is you can attach hydrogen atom, and the name of this product is a piperidine. That is a compound which we got over here. And in our previous lecture we already discussed that how piperidine is a more basic in nature than the pyridine, and that the reason which we already discussed in our previous lectures, right? So once again just let me tell you here, the lone why pyridine is basic in nature, because it fulfilling the Huckel's rule, it complete the sextet, and during the completion of the sextet there already has a 6 pi electrons are there, and the lone pair, whatever lone pair present on that nitrogen atom are readily available, freely available for donation, and therefore pyridine is basic in nature. Whereas piperidine is even more basic in nature. The reason behind it, one general statement regarding the organic compound, those organic compound containing nitrogen atom are basic in nature. This is a aliphatic compound. You know that aliphatic and the aromatic, right? Aromatic and the aliphatic compound, generally aliphatic compounds are the compound which are different. So let us see, if you talk about the theoretically, if you trying to classify aliphatic and aromatic compound, those organic compound, the aromatic compound, those obeys the Huckel's rule. That type of the compound we generally call it as aromatic compound, and the rest of the compound you can say that is a aliphatic compound. But in chemical method, one very simple test, the student of chemistry, while performing organic qualitative analysis, one test is there. Take the small amount of the substance on wire gauze or copper gauze, hold on burner. If sooty flame comes, clearly indicate that aromatic compound is present, and if sooty flame is not coming, then you can say the compound is aliphatic in nature. So this is aliphatic in nature, more basic, and there are two ring residues which can act as shows as a plus I inductive effect, and due to this reason the piperidine is a more basic as compared to as a pyridine. So these are the some of the reaction. In addition to that, the pyridine can shows nucleophilic substitution reaction also readily. So that let us see that nucleophilic substitution reaction at which position. Here we have seen the electrophilic substitution of pyridine, which gives at reactions of pyridine. Pyridine undergoes electrophilic substitution mainly at 3 positions. Now the nucleophilic substitution, nucleophilic pyridine undergoes, here you can write another. This is the first point we have seen. Now let us see another point. Pyridine undergoes nucleophilic substitution at nucleophilic substitution reaction, we can say. reaction at two position, remember this one. And why at two position? Let's see. Here suppose we have this compound, one reaction we are going to see here. This is a structure of pyridine, and now when it is treated with NaNH2, this is known as a sodium amide. Sodium amide is an strong base which can gives the product will be obtained, this one N. Here you are going to get as a this 2-aminopyridine. This is known as a 2-aminopyridine, and that is one of the nucleophilic substitution reaction can give by pyridine. So this is a nucleophilic substitution reaction. One can use the pyridine, and if we substituted pyridines are there, they can use the substitution reaction also. So that are the some of the reaction which we have discussed regarding this pyridine. I think these are the what we can call it as the chapter number 1, which we have studied polynuclear and the heteronuclear aromatic compound. In that we have studied, let me recap the whole chapter. So the name of this chapter is a polynuclear and the heteronuclear aromatic compound. What do you mean by the aromatic compound? And under the poly means many, nuclear means that cyclic compound. Generally we have studied naphthalene and the anthracene. These two reactions we have studied. What are the method for the preparation of those naphthalene as well as anthracene, along with what are the different reaction shown by that naphthalene and the anthracene, that also we have discussed. And after that, hetero means different, nuclear means again cyclic compound, and then heteroatoms such as oxygen, nitrogen and the sulfur. There are 5-membered ring and the 6-membered ring. Mainly heterocyclic compound means what are the properties of that heterocyclic compound. In addition to that, what are the method for the preparation of that 5-membered ring, and what are the commonly reactions shown by those furan, pyrrole and the thiophene. In addition to that, only one 6-membered ring which we have discussed, that is a pyridine. And why pyridine is a basic in nature, such kind of the important properties or the characteristic of that heterocyclic compound we have studied. In our next lecture we will discuss, because nowadays still we are facing the COVID-19 pandemic, and therefore in future also, if according to the future statement about a statement made by some of the scientists, we can say, or doctors, the third wave may arrive, and therefore your academic should not suffer. And suppose in a future there is a examination, and as you are familiar with the exam pattern now, there is always multiple choice questions are there. Whatever we have studied, all the descriptive part we have studied, but in a next lecture we will discuss about the multiple choice questions. What kind of the probable question may appear in your examination, that probable question we will, that multiple choice question or the objective type question we will discuss in our upcoming lectures, means maybe as a tomorrow's lectures. I think with this let us stop today here. Remaining we will see in the next lecture. Thank you. Have a nice day.